In our last video, we took two variables from the early fall '09 class survey, distance to and commute to, and created a scatter plot to assess the nature of the relationship between them. In judging from the scatter plot, it looks like there is some relationship here. As distance traveled to the college increases, commute time tends to increase as well. But as we said, scatter plots such as this are a great way to begin looking at data, but they can be misleading. What we need is a quantitative or numerical measure of the relationship between these variables. And we find that measure in the Pearson linear correlation coefficient, which is a measure of the strength and direction of the linear relation between two quantitative variables. Now, to calculate the Pearson linear correlation coefficient, which is usually referred to as simply the correlation coefficient, we're going to go up to the menus at the top of the screen and click on Stat, Summary Stats, Correlation. And now we need to identify which variables we're going to use to compute the correlation coefficient. So we'll scroll down, and I want to compute the correlation coefficient between commute to and distance to. Select those variables and click Calculate. So here's our correlation coefficient. I'm also going to bring back up our scatter plot. Now, you'll usually see a correlation coefficient reported to 2 or maybe 3 decimal places. And so we'll say that our correlation coefficient is 0.455, and that indicates a moderate positive linear relation between the two variables. Now, in our next video, we'll extend the notion of examining the linear relation between two variables to actually creating a predictive equation that will allow us to take values of one variable and predict values of the other. And this involves a technique called simple linear regression.